This is a rocket engine, a machine that converts energy into motion. It takes 91 of these rocket engines, all kinds and sizes, to power the Apollo Saturn V. They range in size from the 1.5 million thrust of the booster's F1 engine to the small attitude control engines of the spacecraft's command module. The muscle of the Saturn V is the F1. 5 of these engines are clustered to give the first stage 7.5 million pounds of thrust, equal to the power capacity of 154 Hoover dams. The liquid-fueled engines burn a total of 530,000 gallons of kerosene and oxygen in about 2.5 minutes to launch the Saturn V with its Apollo spacecraft and astronauts. After the first stage engines have completed their work and shut down, 8 solid-fueled engines pointed in the opposite direction ignite and slow down the first stage to be sure it stays away from the rest of the vehicle. Since the second stage is practically weightless at the time it ignites, the slushing fuel may not reach the engines. So 8 solid propellant ullage rockets are used to push the vehicle forward enough to settle the fuel against the bottom of the tanks. The Saturn V's second stage engines, called J2s, burn liquid hydrogen, nature's most energy-packed chemical substance, and liquid oxygen. Each engine produces 200,000 pounds of thrust, and the 5 engines total 1 million pounds. The engines burn 340,000 gallons of fuel in about 6 minutes. Solid-fueled rockets again help the stages separate. The same engine, the J2, is also used in the third stage. This engine has a most important extra capability, however. It can be restarted in space. The third stage has 14 other engines, 4 solid retro motors for stage separation, 4 ullage engines to assure start and restart fuel position, and 6 liquid-fueled attitude control engines for stabilization and control. The launch escape system uses 3 engines. One is a solid propellant launch motor to lift the astronauts and their Apollo command module away from the rest of the vehicle to a high enough altitude to let their spacecraft parachutes work. Next, a pitch control motor carries the command module to one side, away from the launch vehicle. And last, a solid propellant motor carries the launch escape tower away from the command module and out of the landing zone. The Apollo spacecraft is composed of 3 major parts: the lunar landing module, the service module, and the command module. All spacecraft engines are designed for operation in space at 0 gravity. The service module propulsion engine is the real workhorse of the spacecraft, propelling it into lunar orbit and providing the power to return to Earth. The service module also has 16 engines for maneuvering in space. The lunar module has 2 main propulsion engines, a descent engine for landing on the moon and an ascent engine for launching from the moon. It too has a set of motors for maneuvering. The command module has 12 engines for attitude adjustments on its return to Earth. This is a space vehicle with 91 engines, each of which has a function, a specific job to do to help man on his way to the moon and bring him back safely.